Welcome to Alphanumeric Tricks. In this video, we are going to see the topic solution of partial differential equation by direct integration. That is, using direct integration method, we will see how to get a solution of partial differential equation. This is possible only when the dependent variables occurs only in the partial derivatives and which can be solved by successive integration. That is, a partial differential equation can be solved by successive integration method in all cases where the dependent variables occurs only in the partial derivatives. Otherwise, it is not possible. Now solve this equation. Dou squared z by dou x squared is equal to 0. Here you have to integrate this equation with respect to x twice, then the derivative will be eliminated. You get the solution for z. So integrating this with respect to x, then integral y constant dou squared z by dou x squared dx is equal to 0. Y here we put here as y constant is z is a function of two variables x and y, and here we are doing the integration with respect to x. So in that case y is taken as constant. Now integration and this 1 dou by dou x get cancelled. So remaining you have is dou z by dou x is equal to constant of integration here is c1. This is for ordinary differential equation integration, but here we are doing partial differential equation integration. So in that case the constant of integration is a function. Inside the variable is the variable which we kept constant is taken as the inside variable. So here y is constant here. So constant of integration is f of y. Then you have to integrate this again with respect to x. So when you are integrating dou z by dou x again with respect to x, that becomes z. That is dou by dou x and x's get cancelled. So you have z is equal to here you have f of y integral f of y dx. F of y is constant, you write as it is. Integration of dx is x plus the constant here is we use it c2, but here in partial differential equation you have to use another function. The variable inside the function is the variable which we kept constant. Y is the constant here, so which is your required partial solution of this partial differential equation. Here f of y and g of y are arbitrary functions of y, but suppose we are doing this problem is done in ordinary differential equation, then instead of f of y and g of y you have an arbitrary constants a and b. Now we will see the next problem. Solve dou squared z by dou x dou y is equal to sin x. Here when you are integrating this with respect to x and y, then the derivative, that the partial derivatives are eliminated, you get the solution for z. Now the given problem is dou squared z by dou x dou y is equal to sin x. This is integrated with respect to x. So integral y constant dou squared z by dou x dou y dx is equal to integral of y constant sin x dx. What is integration of dou squared z by dou x dou y with respect to x? Here dou x and the integration get cancelled, so you have one derivative is there. Dou z by dou y is equal to integration of sin x is minus cos x plus constant of integration here is a function. Inside the variable is the variable which we kept constant. That is y is constant, so f of y you have to write it. This is the constant of integration. Again integrating this with respect to y. This is f of y is arbitrary function, so you have to integrate again with respect to y. You have integral x constant because integration with respect to y, so you have to keep x as constant. Integral x constant dou z by dou y dy is equal to integral x constant minus cos x into dy plus integral x constant f of y dy. Here in this f of y dy is taken as another function because suppose you are having y integral y dy which is equal to y squared by 2. So after integrating you get this resulting term as function of y alone. So that's why we have to take this term as some other function of y alone. Because we doesn't know the value of this, so we just take this way. But here and there we cannot say that. So integrating this, z is equal to minus that is minus cos x into integration of dy is y. So minus y cos x plus here in integration of f of y dy, because f of y is not known to us, but you know that this is the term, this y dy is integrated, you get the resulting factors, you get a function of y alone. So you can write this to be f of y plus constant of integration is phi of the variable x, and this phi is the variable which we kept constant as x, so you have to write phi of x. Here phi of x is an arbitrary function of x, which is the required solution of the given problem. Now we will see the next problem. Solve dou z by dou x is equal to 6x plus 3y and dou z by dou y is equal to 3x minus 4y. Now number that equation as first equation is 1 and second equation is 2. Then you have to integrate 1 with respect to x. That is integral dou z by dou x y constant dx is equal to, because integration with respect to x, you have to take y as constant, is equal to integration of y constant 6x plus 3y dx. This is the term you have. So again integrating this, z is equal to, here z is equal to 6x squared by 2 plus 3y into integration of dx is x plus the constant of integration is f of the variable which we kept constant is y, so f of y is a constant of integration. Number that is 3. Now you have to differentiate 3 with respect to y. Then dou z by dou y is equal to, here you have a differentiation of this term 6x squared by 2 with respect to y is with respect to y we are doing, this term is taken as constant, so constant differentiation becomes 0 plus 3x is constant into y differentiation with respect to y is 1, so 3x plus f of y differentiation with respect to y is f dashed of y. Number that is 4. Why we are doing this is, here in our problem another equation is given dou z by with dou z by dou y, so in order to equate these two we are doing this. So equating 2 and 4, then 3x plus f dashed of y is equal to 3x minus 4y. Again 3x get cancelled, so f dashed of y is equal to minus 4y. Number that is equation 5. Now you have to integrate equation 5 with respect to y. So f of y is equal to minus 4y squared by 2, that is 2 minus 2y squared plus a constant of integration is taken as c, because here ordinary, this comes under ordinary integration. Why ordinary integration is f is a function of y alone. That's why we are putting constant of integration as c alone. Substituting in this in 3, then you have z is equal to 6 and 2 get cancelled, 3x squared plus 3xy plus f of y is replaced by minus 2y squared plus a constant, which is your required solution of the given partial differential equation. That's all for today's video. We will see in the next video with some other topic. Thanks for your time and thanks for watching. If you have any doubts in this, please provide in the comment section. Thank you.